Hello and welcome to Oracle Ace Live. Today, the topic is mastering design patterns for custom business processes in Oracle applications, design patterns for CX, HCM, HCM. I'm Alex Rabinovich and I'm Oracle Ace Pro. I'm happy to be here and to present this topic that I think is very important on this platform. A little of my background, I work with Oracle technologies almost 3 decades, starting from Oracle Database 7.3 with Forms 3, then Oracle EBS Client Server 10.7, and 11, 11i, 12, work with Siebel. Then my cloud journey started with Siebel on demand. We implemented custom processes for Siebel on demand within local servers running Apache Tomcat and JSP pages. Then we started with HCM, well, still before Oracle OIC platform. We expanded Oracle HCM with the Azure servers. And of course, today we're working with Oracle Fusion, Oracle OCI, Oracle PaaS, and using Visual Builder, Integration Cloud, and all the tools that Oracle OCI gives us. So today, as I said, we are focusing on creating business processes in Fusion applications, as this is very common and in every implementation of Oracle Fusion, there is a need for new custom business processes. So let's see what we will hear today. First of all, I'm going to give you examples of number of business processes to make sure you understand and you can relate to your business scenarios and to see to understand how examples we share here can be related to similar cases that you may face in your implementations. We talk about very common approach of need of fetching data from Fusion, doing some business logic and writing back. We'll talk about event-driven processing. Having created the custom business processes, it's very important to show how we expose those business processes to end user. And first, we're going to talk about end user interaction, and we're going to show different approaches of how those custom business processes can be shown and exposed to user. We talk about ESS, BIP Publisher, Classic UI Page, Application Composer, Visual Builder, Studio, and of course, we're going to talk about AI Agent. Agent Studio is it's a new addition, a very powerful addition to Oracle Fusion application. We are going to see it as well. Then we dive into the actual implementation techniques, how we can implement custom business processes. We'll talk about BI Publisher as our engine for data fetch. We'll talk about ESS job, running synchronous and asynchronous processing in OIC. We'll talk about event-driven. We'll talk about creating Groovy-based ESS job. And as I mentioned before, we're going to see an example of how we can utilize the AI Agent Studio. And then we'll discuss, we'll highlight the different design patterns. So you have checklists for yourself, what to remember when you select the correct design pattern. So let's start. So first of all, let's see a couple of examples that I prepared. As I said, you can look at examples and think about the case that you may need to implement in your organization. For example, the P2T process that we all have, that for HCM we'd like to create anonymization process to change the data which is cloned from production. Of course, there's data masking standard process of Fusion. We're talking here about additional change we would like to make on HCM environment. So here we understand we need to define population, define business logic, fetch the data, and then upload it back. Another example that we would like to create a custom business process that would generate subscriptions from order management based on custom logic. One more example about custom uses service logistics. A service logistic have multiple transactions for assets that are installed at customer sites. And one of our customers, they required to create detailed status for asset to understand based on transactions it went through, to understand exactly what's happening with this asset. Would like to expose additional custom fields on standard install-based asset screens, object, or maybe on some custom object attached to it. And this should be done based on, again, query, based on analysis of service logistics transactions and updating the installed-based asset history. Also create deliveries. It's option in order management area that we can create a report to identify the list of orders that you want to create for those orders, deliveries with specific logic. Another example under management area is to automatically release holds and pauses that were created on orders by specific criteria. One more example is for uploading sales order from Excel file. For example, a user enters a screen or places file into a SharePoint folder or runs a process, and this process takes the file was 1, 2, 3,000 orders at the same time and loads it into a Fusion. Last example that from customer that would like to record its customer product usages, for example, and this example that customers send to us files in different formats, could be email, could be PDF, could be CSV, Excel. Would like to take all those formats, extract the same type of information, and create usage information on our subscriptions. As you can guess, this example is very it fits a AI process because you want to utilize document processing of AI to be able to sort of creating writing our own code to parse different formats. We can use AI to do it. Now the examples of data extract, that we can run a report with the parameters, list of parameters with multiple selection. But if we have a very big input list we want to allow you to provide as a parameter, for example, uploading a file with serial number that you want to create a report for those serial numbers, This can be done with another example that we upload a file and automatically we receive a result based on uploaded file. And event-driven examples, master item is created inside Fusion, and based on some logic, we populate additional attributes on the item level. This will show how to implement it with events. Another event that we can talk about catching business event like order status change and notify specific um, business users. So I brought here a list of different example data of custom business process. Of course, it can be related to similar cases. Of course, to extend it, it's not the full list of all possible customization extensions and integration that we do in Fusion. We don't touch here OM extensions. We don't talk about pricing algorithms and others, but I think those examples from our experience, it covers significant portion of what we do in Oracle in the application. So let's start first with end user interaction and see how we can expose a custom business process to users. First is a very well-known ESS framework. Today, users use it for running existing processes like legacy transactions and others. And here, example, you can see on the right side the scalable process that users normally enter, and they benefit of this framework is that users should not be taught a new option, a new way of doing things. They just enter the same UI they use today for other business processes they using today. And when you create a custom ESS job, we can utilize its parameter page. We can use checkable date text list of value parameters with the restriction that those parameters cannot have SQL dependency one with another. There is enhancement request with Oracle that is still not implemented, but I believe at some point it will be implemented, because such option did exist in EBS, but still not available currently in Fusion. We can create our ESS job and connect it either to BIP publisher report or custom Groovy function. There are also other options of Java program, but of course we cannot create our own classes on the Cloud Fusion application. So creating new ESS jobs is limited to running reports, but we will see the report can also submit integrations or custom Groovy functions. With ESS, we can schedule monitor submissions to see the results for synchronous execution, view output for reports. And it's very important to know that every ESS job automatically receives a dedicated role that we can actually connect to any other duty role, and by that grant access to specific users, specific job roles that should execute this this process. In the screenshot here, you can see example of ESS job that utilizes a custom Groovy function that implements the logic. On the lower screenshot, you can see example of parameter definition for parameter of ESS job. Actually, run SQL to show all the files that were uploaded by current user for specific account. And this can be used as a parameter for our reports. For example, user goes to file and import export, upload the file that specific account, and then by using such a query, we can identify what file user uploaded, received in our report, and access it later in our logic. The next option of exposing a screen to kick off business process could be BI catalog report parameter page. It's standard bookmarkable report link. We can use also parameters, but the benefit here that we can create list of value depends. You can see here a report that have business unit list of value and order list of value. So business unit shows you all business unit. Of course, we can add here security and show only user accessible business units. And the second parameter, order list of value, can be linked to the BU and show only orders for selected business unit. Sorry. Such a parameter page can be used for submission of OIC synchronous asynchronous calls, can be used with BI publisher with that allows not just submission of OIC, but it allows also rendering the results in HTML or PDF. And of course, such a catalog element can be secured and be granted to specific roles that can access such a folder. The next option is to allow submission of our report or custom visual builder page from a standard classic UI page, that ADF-based page. All ADF-based pages have edit page functionality that allows us to create links, and those links can, from one hand, take the context of current record and then pass it as a parameter to URL, for example, to a report or to visual builder screen. Of course, if you're accessing analytics or XMLP server URLs, you should be very careful not to hard code the specific environment URL. You use // or you see this API for taking the URL of our current environment to make sure our definitions of our page composer sandbox changes are P2T safe. So after cloning production to test, we don't need to touch it at all. It will work in production, it will work in test without any changes. So our goal is to minimize any required changes when we go between production to test. The next option is using application composer actions or smart CX smart action. So screens like in CX, like assets, subscriptions, contracts, and others available available in CX. In classic UI, there we can use application composer and update pages, create actions. Those actions are written in Groovy. On one hand, can create logic to calculate the resulting URL we are going to, and also take the parameters from the context of current record. You can see below that we can also call here the endpoints available on our Fusion environment. Of course, the suggestion is not to hard code Fusion URLs, but using FA internal notation Again, to create connections that are P2T safe. At the right side, at the bottom, you can see a Redwood example of six smart actions. That it's a nice way to add our own logic or action to take the context of current record and submit REST or other to call other processes. It could be navigation requests, or it could be actually a REST execution here. The next option, of course, when we now go in more and more modules are converted to Redwood. So we should, and instead of having a page compose edit page, now we have edit page in Visual Builder Studio, and we can start utilizing the Visual Builder Studio to create our extensions with this tool. So it's available for procurement, order management, service logistics, and others. Not, of course, in Visual Builder Studio, it's not every screen is customizable. Not every port of it is customizable. It's Oracle developers of each pillar decide what is extensible and what is not extensible. But even with the limited extensions that we have, there are life cycle events that are available for almost every screen, every flow. You can catch such events such as navigation specific page and add our own logic into JavaScript action chain. So here we can, for example, create new sections. Also, the idea is to catch the context and to create URLs to navigate from current page to other page. It could be another Redwood page or a page of a BI publisher report that we've seen before. And of course, we can also create the example of a dedicated Visual Builder Studio App UI screen. I mentioned example of user selecting a file with 2000 serial numbers we want to run report on this, and we can so the screen can do can make it into one place and take the file, upload to UCM to the file input export, submit a report, submit the ESS job, wait for its completion, and expose the output to the same in the same screen without user having running between different screens and waiting for response. Such screens are quite easy to build. And once you build one screen like this, you can always copy it and create another screen with different type of parameters and expose by this one having user expose it to a user and have them run it in one place. Just the idea is to save time and improve user productivity. And of course, as I said today, we cannot talk about exposing this post to user without talking about AI agent exposure. And of course, when we create our new or we publish existing Oracle provided agent teams, we can by using this URL, user can see what agents are available to him to use. AI agent also can be exposed through guided journeys or smart actions in CX. Now we are going to dive into actual implementation techniques and consideration for creating the business process we talked about their exposure. So first of all, let's talk about BIP publisher. Is main tool that can allow us access to a database and selecting data from Fusion, and allowing them manipulation within OIC. So it's very important to understand that, of course, for one hand, their publisher is there. It's very easy to use it to call it by using SOAP BIP call. You see it in the right upper screenshot. But such call has its limitation. First of all, the execution timeout is 550 seconds. The output size is limited, and of course, such online execution competes with online users of Fusion and actually may result degraded performance of online users. So another option of running such a report and getting larger allowances for runtime and also for the output size is using the ESS schedule option, asynchronous BIP call. You can see in the lower screenshot that we can submit ESS job running BIP, and we can enter a loop inside OIC. We waiting for ESS completion, and once ESS is complete, we can download the resulting file and then proceed with our logic. Of course, we can use the callback approach, and we can submit with enable events ESS job. But then in this case, we'll have two separate flows in our in OIC. So flow one just submits ESS job, and the second flow will be kicked off once the job is complete. So they want to analyze and to see together those very small, difficult to analyze. That's why we usually prefer to have this loop within the integration that waits for ESS completion, that still allows us to see the result of whole processing in one place. Of course, such integration should be asynchronous integration because of the limits. Because synchronous integration can work only for 5 minutes, as asynchronous can run up to 6 hours. So the next topic is when we use Data Publisher as our fetching tool, we should prefer using data XML, the data CSV option, to skip layout generation, because we need just data. We don't want to wait for post-processing to work, because we can just take the information from XML or CSV. And the nice part that is today, I saw that is not quite widely used, but in our team uses a lot, using the lexical variables in BI Publisher that allows us to dynamically generate the SQL. In some cases, like demand planning, MSC, the planning tables, that could be dynamic, because the tables generated based on plans, and also accessing custom objects. The mapping also is not constant between environments. Of course, if you have after P2T, all mapping are the same, but when we're talking about initial development, the mapping may change. So this option of ampersand something is very, very convenient when we want to utilize dynamic SQL. Of course, when we run our queries, we need a tool that will allow us doing the query, and then different free and paid tools available on the market. One of tools is our tool of series of solutions that can be downloaded from our own web store. It's free tool, and that you can just run queries, run explain plan, and export to Excel. And one of the latest addition that we added is ability to run very large queries up to 320 kilobytes of SQL. That previous limitation was 32 kilobytes. And you can see here on the right side, today we have about 1,700 weekly users using this tool. You can use it freely. It's here, of course, and then also other tools available on the market. Now, in addition to data fetch, of course, we can also use BI Publisher to access UCM. So there's pre-built connection, which is a FA UCM provisioned, that you can access from data set in your data model. You can access UCM by using document ID. If you remember the option of list of value showing us list of files uploaded by user, we can use those IDs to query the revisions table and then to access the UCM connection. Of course, limited to 32 kilobytes and only for text files. Again, there's other techniques that we can talk about later about utilizing a bigger files with silos to custom objects. But this example is very useful that you can upload a text file of 32 kilobytes. You can parse it, for example, CSV file. You can parse it like here in the example and use it in your other data sets. And now, if we talked about a limitation of UCM access from BI Publisher of 32 kilobytes, here was an example of how we can utilize Oracle's very powerful database features, allowing working with XML and JSON with a big silo fields. So an example that you can see here that I talked about ability of uploading a big Excel file to and process it as to load those orders into Fusion. So the example that you see here, let's say user uploads CSV file, OIC helps us, or VBS helps us to convert this file into XML. XML is loaded into a single silo field of a custom object record. And then by the left query, you can actually analyze all at once. We can read all the lines of this XML by using XML table, join it to any table in database you want. So it's much more powerful than reading this in OIC and running a report one by one for every record. By this option, we can take the full file, thousands of lines, load it into a single silo field, and by single SQL query, we can validate and enrich this information that can really save time. On the right side, you can see how we can use JSON object, JSON table to JSON array to generate JSON payload out of SQL, from SQL that you're running on our Fusion database. And this payload can be used by using OIC binary input option, we can send this payload as is to Fusion REST API. So the next option also need to make sure that we not forgetting that we have option of using layout options of the publisher. We can generate PDF, HTML, Excel, and we can also use XSL text or eText to generate structured text files like label printing and other files needed for integrations. Bursting option is very, very powerful that allows us not just to send emails, which will be very carefully used with P2T process, but we can automatically send the files from their publisher to SFTP. We can automatically upload them to UCM as a part of bursting and combine it with OIC post processing. For example, I would like to run a process that does some runs as a query, and for each order that part of the scope generates a report and attach it as a PDF attachment to the order. So we can do it with this option of UCM bursting and then OIC that identifies the a file and attaches to the relevant order. Now let's talk about the vector design pattern for custom business processes that utilizes synchronous processing in OIC. So, to implement synchronous processing, first we should be aware of limitations of such processing in OIC. Have a 5 minutes limitation. So to do it from BI Publisher, we can utilize one of two options. We can create generic HTTP connection in OIC. We'll see later an example. So it allows only one place to handle after P2T. Or we can use a SOAP connection, but this SOAP connect dedicated per integration. So it's from my point of view, it's less convenient because it adds every usage of SOAP connection from BI Publisher to OIC, adds additional point to change after P2T. This allows us to map report parameters from report to integration. And it's very important to know that there is a Fusion app request ID. It's a built-in parameter, that passed by ESS framework to the publisher. And we can utilize later on to understand who submitted the job, what of the user email, so we can actually get back and send or do some additional processing, knowing what was the ESS that called this process. So the benefits of this approach is, first of all, when you run this ESS that submits a report that runs OIC in synchronous mode, first of all, ESS is running in the ESS screen as long as OIC is running. And if this OIC resulting XML is sent back to BI Publisher, it can be rendered in nice HTML and PDF format. If some error happens inside OIC, it can be exposed in ESS output. The drawbacks of this approach is that we have a very hard limit on OIC runtime, which they can run only up to 5 minutes, and it's not good for large volume processing. And of course, when we run process, submit process from BI Pub that runs OIC, all updates that are performed by OIC integration are registered on OIC service user and not on current user running the ESS job. So if how we can do it, If we go to BIP administration, usually we define one connection of call OIC or any other name you want to do, and this connection points to your Oracle Integration Cloud instance. Of course, you should. The best part is to have OIC instance for each environment of Fusion. So this only have a server connection without specific integration. And this example of connecting to a specific OS integration by using SOAP connection. And here the example inside BI Publisher, how we can map the parameters from our BI Publisher report to the parameters of our OIC. You can see you can create a parameter and then you can map it to the parameter of your publisher report. You can use parameters, or of course, the hidden Fusion Apps Request ID parameter that passes the ESS job ID parameter. So now, as I already explained before, this synchronous integration is useful for small volume of single record processing. We can create HLPDF output, and we should properly handle exceptions in OIC integration. So if it fails, still to return XML to BIP to allow it to be shown in the report in the output of the ESS. Now let's talk about asynchronous processing. So as you know, in OIC flow, which is asynchronous, that what defines asynchronous if it's post without any response or SOAP one way. This, of course, scheduled. Those integration flows as asynchronous, and they can run up to 6 hours. We can still trigger those integration by GET from OIC. Usually what we create two integrations, one caller integration and one the actual processing integration. In this case, it's very important to pass Fusion Apps Request ID because this will allow us in OIC integration understand who runs the integration, what the email of the user, and whom to notify. Because in comparison to synchronous operation that is running as long as OIC is running, with a synchronous processing, user sees that ESS completes immediately. Just does the submission. But the actual processing is done on the background. So we should notify user and the different ways how we can notify. The best easiest way to notify by email, we can upload results to SharePoint or some other ways, but again, it's done asynchronously. The benefits of this approach that you can have much bigger processing time. We can run up to 6 hours instead of in comparison to 5 minutes. We can utilize full OIC capabilities. Of course, we can. This is the place we can utilize other ESS jobs and submit reports. In this case, we prefer not to do online report execution. We prefer doing it with ESS job submission waiting with busy wait. So the drawbacks of this approach is, as I said, it has completed immediately. We don't see what's happening. Although we did, in some cases, we did a combination of submission data set and SQL data set that use business log sleep to wait until OIC completion. Like with synchronous processing, the last update user is voice service user and not current processing user. And of course, if the process of the OIC submits intermediate reports during this process, those outputs are not visible by the submitter user because they are submitted by service user. So in this case, if we need to expose those outputs to user, we should either email or attach it to access a business record or some custom object record that a user can see. Here you can see example of a utility that we use in many integration that implements the asynchronous approach. That by using Fusion Apps Request ID, we can identify our current request, and with a scheme users endpoint, we can find the user email. So this will allow us to notify the user that actually submitted the ESS job. So this approach, all that understood, is suitable for large volume data manipulation because we have up to 6 hours of execution time. We can also submit other ESS jobs with the running reports. We can download data, process. Of course, the actual update of Fusion can be achieved either by REST API, MVDI, HDL, or import management. For CX, we want to do mass update of custom object or its objects exposed to import management. Of course, we can only securely exposed to the data can be exposed securely to users. And here we should design properly the error handling to make sure if something happens, if OIC process failed, we need to notify user because in ESS, in the ESS level, we don't see anything. So example of large volume processing, user uploads a file to a SharePoint directory, submits ESS job. Is the job submitted, calls OIC, OIC downloads file from SharePoint, converts to JSON, uploads to a single record of a custom object CLOP field. The CLOP file is parsed by a BIP report that generates resulting set of JSON payloads for each order. All the REST those JSONs are applied in the REST API. Orders are they updated or created, and users notified by email or in addition by additional result files published to SharePoint. So you can see now let's talk about events. This event, for example, is quite simple. Item is created in the system. We want to create populate certain attributes of item with by our custom logic. The event example, there are many events available. Just consult with using documentation to see what you want to use. Of course, there are generic events like ESS, PDI load completion. Of course, specific events like item creation update, work order, sales order, status update. Using OIC with events is P2T safe because there is no connection defined for Fusion to OIC. OIC is listening to events. The drawback of event that there is no real SLA because it's near online, but from our experience, it can take some minutes for this event to happen. And we have also cases that event can be lost if, for example, user password change, so that And event is triggered, but due to password change is lost and not processed. So usually with event processing, we should complete it with some other verification process that can catch unprocessed events and do it with other process. In addition to standard events that we can catch at predefined events, Oracle allows us also to listen to custom object events. To enable this option, we should turn on the profile I mentioned here, custom object events to yes, and then in the application composer outside of sandbox, you can generate integration event. This will allow you by changing any custom object, generate event, they can listen on this event inside OIC. The benefit of such approach, of course, that there is no P2T impact. It's asynchronous. So if you just get event, you don't get response immediately. But this is very, very useful when we look back here. For example, if we want to have a custom screen that once we want to trigger label generation. So if I add the custom object, we can see that OIC is triggered and they can do anything you want. The next very important, I think, very useful technique that we start using and we like to show here, promote its usage, is usage of a custom business process implemented fully in Groovy. This is first of all exposed as standard ESS. So you can implement your logic completely inside your application without need of OIC. There are implementations that do not have OIC, and this can give you a lot of flexibility of running any type of custom logic without working with the OIC. In comparison to workflow, this gives us 30 minutes of execution, and we have a full control of what's going on. The implementation of Groovy function, first of all, you can go to official documentation that says that to use Groovy function, you should create a function without any parameters. But I did publish a blog on this topic showing how the Groovy function without parameters still can access the ESS job definition, runtime definition, and read the parameters passed to the ESS job. So this could be it's really flexible, not just processing without parameters. It can be also use parameters as part of our execution. We can use any data manipulation. So of course, we can use a view object that is exposed to CX, but we can also use any REST endpoint, any SOAP we can use within our Groovy. And of course, as I mentioned before, to be P2T safe, we should make sure that we always use FA internal URL and not hard coding, dev test, or production URL. It's important to understand that when we develop integrations with OIC, we don't really think about permissions because we always use service view that has wide permissions. When we design ESS job in Groovy, knowing that the user will run this job, we should think like we do it with Visual Builder pages. We should think what REST API, what SOAP API is available by user license and access. And because if we are trying from our Groovy to call REST or SOAP API, which is not available for the user, this will error out. So how we can do it? You can see here that we can copy existing schedule custom Groovy object function to a new ESS and pre-populate object and function with our custom object and our function we want to use. In this example, you can see that we added two more parameters here to the ESL definition, because you can use, as you saw before, a list of values and checkboxes, whatever you want. And here's the example that we actually found the way how by using SQL, we can actually take the session ID that is exposed to the Groovy, go back into session attributes in request properties of our ESS job and get access to the parameter that was sent to our ESS. This gives you actual access to any attribute, any parameter you want. And now, of course, as I promised, today we cannot finish talking about custom-based process without talking about AI Agent Studio, which is a huge addition to the abilities that we have as implementers of the Fusion application. AI Agent Studio comes with pre-built templates and processes that you can start using out of the box. And I just encourage you to start using it. And for exploration, you can test existing out-of-the-box processes, create your own processes, and of course, try to utilize power of LLM, for example, for unstructured file processing. And this is the example I want to show you here. In this example, I'm showing you out of the box what to requisition process that deployed by Oracle Connect to analyze and see how Oracle defined prompts, how they used LLM and existing options in Agent Studio. Here, the business example, I want to show you how it can be implemented by using AI Agent Studio. So as I said, a user receives multiple formats of files from customers that shows our product usages, and that at the end will result charges of those customers. Files could be CSV, Excel, PDF, even MSG file, which is email, they will print to PDF and then shared as then used as PDF. So those different files, the order of columns could be different. The columns name could be, for example, I can call it item, product, SKU, but LLM knows that all those are the same. So our goal is to extract the common information, let's say product, quantity, date, from those files, bring it to common format, and then call backend REST API for each record extracted from those files. And we'll show you in this demo, first of all, how we use. So we just created OIC integration that simulates, shows example, we're receiving usage information, we ascertaining it as is, but of course it can write down to subscription or to any other internal system. Agent Studio custom tool that actually allows us to point out to a URL that invokes OIC integration. Custom agent utilizing a multi-file processor tool with prompt that we created that actually can parse all those different formats and bring us back the result in common format. And the custom agent team of workflow type that can just utilize the agent that, for parsing, and it can create loops of the results and call external APIs. So let's see how it can be done. This example of OIC integration. See, just a demo integration that's showing that, of course, when the best part is not to call OIC for every single record, because we're not wanting to misuse and not from performance perspective. But this example of receiving item, quantity, and date, and we returning success that item was registered on a specific date with the quantity. It's just example that we'll see later how we can use it. Here's example of creating a custom tool within Agent Studio that points to our OIC integration. You can see it here, of course. Today we use OIC, try to use projects as much as possible. This is the best practice of Oracle for OIC. Here you can see that we actually creating definition of this process inside Agent Studio. And then here's the example of agent that receives file from chat, of user chat, and then we define here in English, in the prompt, we define what we want to extract from the file and what the format of JSON array you want to receive as a result of this agent processing. So it's very strict. Again, I used Grok, for example, to fine-tune those prompts. So we can use AI to generate AI prompts. And this is an example of agent of team that actually uses the agent that we've seen before to parse the chat that we are currently communicating with our users, and then for each record that came out of this chat, we're looping and calling our REST API. So here you can see how we tested. So the custom usage processor, I uploaded here XLSX file, PDF file, and CSV file. All those files, the order of columns was different. In PDF, it was different place at all. It was many other columns. And I sent all those files, and the result of processing, you can see those files processed successfully, and records from all those files were converted into a common structure. And for each record, a REST API of OIC was called. So this is great. Of course, it gives you what example of what can be done. Of course, from here, of course, I suggest you to utilize it to read existing prompts and see how it can be used. But this gives you total new level of ability that we did not have before. So now let's summarize and talk about design pattern selection. So of course, you've seen different types of implementation and the user exposure. Of course, we need to understand user UI and business requirements that are part of our definition of the request. Of course, you should consider a security license model. As I said, the service user can access everything. Current user can only see whatever is granted to this user. We can consider the way to access submission, what type of submission to use. We talk about permission and whether we must have current user marked on every record, or it's okay to have service field. For example, remember that using update from Visual Builder screens or through Groovy actually have marks our user, the running user, on those records. Also, we should understand the volume of processing, understand if single record, multiple records, to select synchronous, asynchronous mode. We should think about error handling and what happens if we reach 6 hours and the process is actually stopped immediately. We can think about maybe check a bit before. And of course, we should think about exposing the intermediate artifacts. I said if OIC submits a report, this should be shared with the running user. It cannot be easily, it cannot be not out of the box because the report is submitted by integration users. It should be shared by email or attachment. And of course, when we run when we do our implementation, we should consider P2T actions. So to minimize the P2T, so make sure that when we clone from production to test, we have zero to small number of actions to be done. Okay, thank you very much. I really enjoy preparing this presentation and sharing this knowledge and experience with you. That is actually that we gained by implementing the solution with our customers. You're more than welcome to send questions to my email. You can connect to me by LinkedIn, and of course you can go to my blog and see other solutions and techniques that we are sharing with anyone that wants to utilize it. Thanks a lot, and enjoy, explore, and proceed with implementing Oracle Fusion applications. Thank you.